I think we're recording. Hello.
Hello.
This is Lyle Vanfossan and Scott Brunton. We are going to do this example of our PySpark with in Colab. This is for ICP4 for knowledge discovery management. So this top part here is pretty standard setup for PySpark. We needed to install some of the libraries, and then also here is just setting up JDK8 because I think it's necessary for Scala to run on, which is, I believe, what PySpark is actually built in. So we already have all of this kind of ran, so we don't have to do that in the video. But as I scroll down here, it's more of the setup, just different installations. Here's some Python installations that we had to do. Setting up some of these environment variables, the Java home and the Spark home variable. Again, more setup stuff here. And going down to here, we actually start working with Spark. We set up the Spark session variable. And here we add in our different data sets. One was originally added in the original presentation, and this one was added in by Scott, and I'm going to hand it off to him so we can talk about that.
So here we have both of our data frames that we built out in Spark. The one we have with our original data, and this other one I just built out in Mockaroo, which just builds random data sets based on your criteria. For that data set, it is supposed to represent a customer address table that is related to our original data table because with the same customer ID as their relation. And then down here, we're just mounting to our drive. And at this point, we'll go over the transformations. And for this first transformation, we use Spark SQL and actually wrote in a SQL query to return, to join the tables and just limit our view on it and return only the values that were from a certain state and of the internet service of fiber optic. And at that point, we drop our tables just for resources more than anything. The next transformation we did was a left semi-join using the Spark built-in join methods functions. And what this does is it just returns the left table that has the matches from the right table, but does not return any of the matches from the right table. And then our final transformation was we were using the distinct method on the internet service table, column. And for the first, we show how many unique rows are in the table for internet service. And then once we use the distinct, we show that there is only 3 actual unique values in the internet service column. They're displayed below. And that was all of the transformations. Lyle?
Thank you very much. So I'm going to talk about some of the actions that we performed on these data sets. So the first action is basically we're going to do a group by, which is actually a transformation, but for the sake of the outcome of the aggregate that we're going to do later, we wanted to group it by gender. So male and female, the only 2 available in the data sets. But basically what we did is we grouped these by gender, and then we did the aggregate of the tenure, and we compared the different average tenures of individuals based on their gender. So you can see here in this table that was generated that females had an average tenure of 32.24 years, and males had an average tenure of 32.5 years. The next action that we did just takes our data frame and it limits the number of rows that we want to have returned, and then it collects them as a list. For here, we just did some beautifying and some of the printing that we did. You can see that we just collected 22 of these rows, and then we just printed them out row by row. As you can see here, the return type of the new object that we created was a list, and the length of it was 22. And here's all 22 of our rows. And then finally, the last action that we did was to just take some small samples and then print out just the count of the various samples with replacement and without replacement. So you can see here, this is a sample with just a seed of 0. We only got like 1% of all of the objects in our data frame with their placement, and we did the count of those numbers or those rows in that sample. We got 71, and then without replacement, we did the same thing, and we got a count of 58 in that. So I think that's pretty much it. So thank you very much.